Hi, everyone. Thank you for joining me. For those who are in the Jitsi Meet, thank you for being patient while I'm going through some of these technical difficulties. Welcome back to uh, Common Lisp Study Group. I'm your host, Ron Baden with Atlanta Functional Programming. We have been off for the past year or so on a long hiatus, and I'm glad that we are getting back to kind of the course of new business and hopefully, we have some interesting adventures to show you, new libraries, possibly brand new projects that I've been thinking about that we should be doing while we're, obviously learning more and more about what's available, what's the limits of which we can do stuff in Common Lisp, as well as hopefully give you guys some ideas and convince you that Common Lisp is still a very viable programming language even today to start new projects in. Today, we're going to be discussing a library called trivial-extensible-sequences. This is a library that I've been on and off been looking at since its release a couple of years ago, I believe it was now. It's a particularly interesting library, but in order for us to do that, I need to kind of give you kind of some motivation in order for you to understand what its purpose is. And so for today's agenda, we're going to kind of do a brief overview first of sequences, okay, and interacting with sequences and currently the current limitations of sequences available inside Common Lisp. And these are the built-in sequence types that's available. Many of you may not know this. Some of you may already do if you've been living in the hyperspec. But sequences are a base type inside Common Lisp. But the way it was currently standardized, um, it came with some caveats and some limitations. And this ends up being the motivation for user extensible sequences, which ends up being called extensible sequences as well. You can use either or. They're usually used, synonymously to mean the same kind of thing. And that means being able to create your own sequence types and still leverage the available generic algorithms that are inside Common Lisp to actually interact with your own sequence types. And that will give us the motivation of talking about trivial extensible sequences. After this kind of brief presentation, I will be getting and diving into code. Um, it's just I wanted to kind of give you guys some brief introduction to um, the library and its motivations before we actually kind of like get started on like just looking at code. So, like I mentioned earlier, sequences are a base type inside Common Lisp. There are different subclasses. Most of you are aware of the available ones, which are lists and vectors. Um, Multi-dimensional arrays do not technically fall under this realm as a sequence. Although one could argue that if depending upon how you define how the multi-dimensional array is being accessed, you could treat it like a sequence. But for the sake of my understanding of the hyperspec, um, we are restricted to ordered collections of objects that can be accessed iteratively. Okay, are defined as being sequence types inside the Common Lisp library as it stands today. One interesting thing through my discovery of this is that nil is also technically, I mean, it makes sense, but it is technically treated as a sequence, and it is a sequence of a length 0. So if you pass in nil to any of the sequence API libraries today, the library will return the appropriate, it will not fail on you as far as I can tell. And it will not throw up an exception or condition to actually get you to decide what restart should be actually kind of leverage. And this is kind of important, specifically when you start wanting to talk about uh, base cases and reductions. and you want to reduce particular like algorithms to some sort of identity value, you could leverage actually using nil for those situations. Although, you know, for the pure functional programmers in the audience, that might be a little of a bitter pill to swallow, just mainly because, having some sort of identity element is probably better than actually defining um, and using nil directly for most cases. With these two lists and vectors, there is something to know, a historical note. Up until Common Lisp actually got standardized, list and vector, from my understanding, actually had their own separate APIs. You would be interacting with list and vectors with different APIs, much like you would in some Lisps like Emacs Lisp. You have vector push, vector add, and so forth. Um, in fact, I think some of those are still available too as well inside Common Lisp. We can actually go and double check that. I'm just right now going off of memory, so forgive me. Uh, The reason why sequence was created was to kind of unify these two things, because conceptually both of them are um, essentially the same kind of concept, although at the data structure level and data access level, they have different behaviors. And only at those particular pieces would you want to profile and probably switch to a different data structure. And one of the advantages of using sequence and having generic algorithms operate on sequences means that you could switch between the different data structures and get performance benefits just by merely changing the type of data structure instantiating, but not necessarily code on how we're actually interacting with that sequence type. There are actually many functions in the standard library to interact with sequences. This is not an exhaustive list of what is available, but it is a good number of the common operations that you would do with interacting with sequences, whether you're using um, what's it, lists or vectors. Okay. And for folks who are probably used to seeing code where we're using, like, say, mapcar or mapcoder, I mean, mapcon or mapcan, uh, one reason why those don't necessarily fit into these is because they kind of are restricted to using lists specifically. And so they don't necessarily fall as generic sequence operations that you would actually instill in here. All right. Um, all of these are actually fairly well supported and fairly actively used. A couple of things to note here, and this is something I completely forgot, is yes, if you see on the right hand side, there are four functions that look very similar to each other, but they do have different purposes. I will encourage you as an exercise to go through the common list Piper spec to determine those differences as to when to use them, just because I still am not entirely sure whether I should use a delete duplicate or whether I should use remove duplicate. Sometimes my own self, and especially me trying to encourage more of a functional style with my own coding and my own habits. I know some of those are destructive operations, and we have to be careful as to which ones you should use and which ones you shouldn't. So with all these um, APIs and these two, the fact that we have a base sequence type, and we could actually we have subclasses of list and vectors um, available to us. A big question now then becomes, well, what are its limitations? Like, what is it that that we can't do? And I will show this to you in our code example later on. But in a nutshell, currently you cannot define um, a subclass of the built-in sequence types. It will, in fact, I think, throw a condition saying that this is not possible. All right, and this is a pretty big limitation, mainly because there are more sequence types than just list and vector. We know many of them in uh, other languages. In C++ alone, for example, and I can only go off of memory on this because this is my day-to-day language. You have double-ended queue, you have priority queue, you have min and max heaps that could be treated like sequences as well. Yes, internally they could do percolations and readjust the data structure whenever you pop an element and push an element onto the heaps. But sequence operations can still be leveraged in those situations too. And there are many others inside of uh, the C++ API. Hell, even in Common Lisp, we have hash tables, and although hash tables exist, hash tables aren't able to be treated like sequences. al- And that's besides knowing that technically you could treat a hash table internally as a list of key value pairs or vector of key value pairs, depending upon how you implement it. And that's important because sometimes it's useful to be able to iterate through the key value pairs. Um, themselves. And in fact, in Common Lisp, for hash tables, we do have map hash to actually go and do some of that for us. But it would be kind of nice to have the ability to, use one common API for all of this. Um, a second point, and this is even more important of this subclassing, other than the built-in data structures that we could probably add to the Common Lisp library, is that one can also treat some types that one designs for a system has sequences. Okay, and an example of this is like event streams, all right, or just streams in general. Streams could technically be treated as sequences if you think of a stream as being a lazy evaluated sequence that hasn't completed computation yet. So you could get, you know, what has currently been retrieved on the stream as being your initial values and collections. And then the only problem that you would end up having is you wouldn't be able to compute the length of the stream or fixed stream until everything has been retrieved across the wire, or if you're reading from a file until the IO operation is complete. So this becomes very useful. And what this ends up resulting is a lot of the extensions and applications that people have built over the years on top of Common Lisp have resulted in disparate APIs that dealt with essentially non-standard sequence types with their own APIs, but underneath, conceptually, they were all the same kind of concepts, and that's kind of an important thing to kind of recognize what this kind of design limitation ends up resulting in. Some examples of this is uh, eh, I believe Flexi Streams is an API, has its own sequence API for dealing with sizes of their sequences types. Climax, the Common Lisp implementation of Emacs, contains some sequence APIs for dealing with sizes of buffers and things like this. And obviously, if there was some way for us to actually leverage a good portion of the standard Common Lisp API, we would be avoiding a lot of this effectively API duplication, where conceptually everything is the same thing, but unfortunately you have to still do a context switch to realize you're no longer dealing with a standard sequence type. You're now dealing with a user-defined sequence type, or even a sequence type that is not part of the standard library. Um, I'm going to just at this point mention if anybody has questions, feel free to post throughout this discussion, um, either in the Jitsi chat or in the YouTube stream chat, and I will more than likely, I'll gladly answer those questions through the course of the discussions when I see them. So back in like, I think it was 2006 is when I seen this, so it's about 17 years ago. Christopher Rhodes. Hmm. Okay, a mental note to myself. It looks like there is an issue. 1 second. For whatever reason. Oh, my apologies. Let me do this. just noticed that this is a little problematic to read for most folks. So give me just 1 minute here. Um, do this. And let's see if I get to, oops, there we go. And there we go. All right, had to fix my presentation there. Um, so this is coming up on 17 years, I believe. This might be even older than this, but this is the first time that I've actually seen this paper. Christopher Rhodes wrote a paper and slash proposal called user extensible sequences in Common Lisp, where he provides a base class for defining user-defined sequences and protocol support for the current sequence API for those user-defined sequences. The goal of the paper, at least at the height of which I understood, there may have been other goals. It has been portability across different Lisp implementations, because it was difficult for a person to write a library that would, say, leverage stuff inside SBCL, which had, um, you know, some implementation of how sequences worked with its own sequences API, or even the ability to base class its sequence type. But if you try to use that code over in, say, Clojure at the time, you would be unable to, just because Clojure didn't have any sort of extensible sequences type inside of its Lisp implementation. So portability was a big thing, and allowed us to, kind of generalize some of the sequence operations a little bit further. But additionally, I think one goal of this paper was also to reduce some of the duplication that ended up happening, the API duplication that ended up happening, because the base sequence type was not extensible. Uh, this paper actually ended up having its canonical implementation implemented inside of Steel Bank Common Lisp, or SBCL, under the SB sequence, I believe, package that you could actually go and directly instantiate if you were just using SBCL. But other Lisp implementations have actually adopted this, and that includes Clasp, which is, as many of you know, the more recent Common Lisp implementation that happened within the last decade that provides support for like C++ integration, as well as Armed Bear Common Lisp, which recently has provided us with a more updated version of itself for interoperating with Java. The ARM Bear Common Lisp implementation is now, I think, supporting up to, I think, Java 13 or Java 14. They're looking at before it was on Java 8 for a very long time, and I think it was within the last maybe 4 years, 3 or 4 years, that they've updated it to the latest Java and the latest LTS, if I'm not mistaken. And they've been now actively trying to maintain that. So for the Java programmers that are out there, if you are looking at Clojure, and you want to do some stuff, you have Armed Bear Common Lisp at your disposal with the ability to use uh, user extensible sequences. All right. Obviously, looking at this list, we only have 3 Lisp implementations that are all in active use. Okay. There are many others out there, Clojure being one of them, CMUCL being another. Um, let's not forget ECL, as well as uh, what's it? At a time, you had Mocal. Okay. Um, so the this becomes the motivation for implementing um, trivial extensible sequences. Trivial extensible sequences is a library. It's created by Shinmera. That is a portable library that implements this protocol. All right. For implementations that do not implement the extensible sequences protocol directly in base type natively, um, trivial extensible sequences provides fallback support for all the basic um, APIs. Okay, and it is available on Quick Lisp. So in order to simply load this up, um, you can just simply run quick load trivial extensible sequences on your REPL, and you will be good to go, and you can hit the ground running. We will in a moment see code uh, and dive in on actually creating some code. But I'm going to pause here just for a moment and see if there are any questions on just generic sequences available in Common Lisp or in just some of the motivations behind this that people might have. Okay. For folks on the stream, as well as folks in Jitsi, give me a moment here to just quickly set up here, and I could reshare my screen. Just give me just one brief moment. I have to exit out of this guy. Let's see here. Okay, and add this over here. Yeah, just give me 1 second. Alrighty then. Let us go to window, this guy. All right, so let's create a quick project to kind of illustrate some of this that we just seen. Okay, now what I'm going to do is I'm going to first create a project. I'm going to use CL project to actually create my Common Lisp project here. For folks who are wondering what this is just a simple project generator that allows me to set up essentially as-diff based projects, and it is created by uh, I think this one is created by Fukamachi-san of many projects that he creates. So wrong project, local projects, and just create a quick workshop on this guy. And let's say that we are creating. So there's a couple things that we need to kind of specify in order for us to actually work through our discussion today, and that is, the name, the description has to be available. A little tutorial on trivial extensible sequences. Now, while I'm setting this up, I'm going to mention that I will be posting this in the Atlanta FP GitHub repository. I will provide details as to how to grab that in the YouTube description, and at the end of the meetup, I will also post it on our um, uh, meetup page in the actual meetup itself. Just so for folks who wants to go back and look at this, they can do so. All right, so let's go ahead and load this guy up. Uh, for folks who are just joining in or aren't familiar with some of the infrastructure boilerplate that I'm doing here, basically, Roswell has many folks who have been following my live stream knows is a library. Well, really, it's a tool that allows you to run multiple Lisps, whether it be SPCL, CCL, what have you. It has support for at least 10. I think most of the active Lisp distribution implementations are out there. Right now, for the sake of today's discussion, I am going to be focusing on SBCL because of the fact that, again, um, the the extensible sequences library first um, was first implemented in this. The protocol was implemented in this, and it will be the easiest one to kind of show you the APIs and stuff. And then, time permitting, I will go ahead and try, in the ongoing experimental piece of our discussion, uh, other implementation to kind of just show you that you could just simply switch, and you can reload um, your Lisp implementation. It'll just work out of the box, using extensible sequences. That is. So, um, but when you're using Roswell, the one thing that you want to be aware of is, and this is actually the nature of how image get loaded, right? Is It's using a packaging tool called another system definition facility, or ASDIF. Okay, and ASDIF uh, uses a central registry to specify directory locations where it's going to look for Lisp systems. That's essentially systems that are defined by this .asd file. Um, I have a whole actual episode on IHASDEF in the Common Law Study Group archives. So I'll encourage you, folks who are curious on some of this project generation stuff, to look at those. But very quickly, this local projects, if you just have Roswell installed and you create your projects in local projects, you don't have to actually go and tell ASDIF where your project is actually located, so it will be able to find it and load it into your Lisp image. That's kind of why it's actually there. All right, so we have our dependency on trivial extensible sequences. Before I load this project, I'm going to show you what will happen if you try to create a um, sequence, okay, using the built-in sequences. Okay, so I'm not entirely sure if this is going to fail here on SBCL, mainly because of the fact that I don't know if SBCL has switched between sequence and SB sequence and just made SB sequence the default one. So this might not actually fail on this, and I would have to switch to a different Lisp to kind of show you what we did. But let's try it out. So for the example that we're going to kind of cover for both trivial extensible sequences, this is a very nice example. I was going to come up with one with generators, but that was a little bit more that requires a little bit more of a complete implementation for generators as sequences. Mainly things for defining what is a length of a generator and things like that would be a useful thing to kind of keep track in mind. So there's different ways of defining it. But the documentation for trivial extensible sequences actually had a very nice, interesting one where you could just treat a value, a single value, has a sequence, okay, regardless of the type. Okay, so we're going to kind of reference this one, and I will give um, appropriate uh, credit here just to Shinmera for coming up with this one because I should have really thought that this about this being has trivial and stuff. So um, his documentation really kind of like really helped out here. So thank you, Shinmera, for this example that we could cover and kind of review. Um, so when you're defining a sequence, obviously you're defining it like any other class. Okay, this is kind of important to be aware of. Um, and when you define it, obviously you would have to subclass it has sequence. Okay, and for whatever reason, I see that he specified standard object, but I was under the assumption that uh, this would automatically be subclass from standard object. So I'm just going to go ahead and leave this out for now and see what will happen if I don't incur it. And obviously, this value as a sequence need to hold some sort of value that we're going to constantly return when we provide it. So we're going to go ahead and provide the value. We're going to say that its initial form is just going to be throwing an error. So it doesn't provide any sort of default value. And you need to specify one when you're constructing the object. And then I'm going to go ahead and add an accessor, which for most of you folks know, this will actually allow you to read and write to this value. Okay, and let's go ahead and see. This is kind of what I was not expecting. Okay, so let me see if I could get. Um, do I have another as well? List. List installed. Heck. Um, uh, why is this not working? I think. Okay. My apologies. For some reason, Roswell is giving me a little bit of trouble. Okay. Okay. So don't remember if I have fixed this inside. If I could switch to a different Lisp, but we will see. Okay, so this is actually going to give me a thing. Okay, so one second. Let's see if I could just where is it? It was sorry, just technical difficulty here. because I am looking for the fact I originally had this all set up so I could switch between different Lisps very quickly. And I think recently that has been messed up by some changes that I've made. Um, you know what? I'm going to show it this way, and this will. And I'll come and fix to this. I think apologies. We're going to just use eShell for the sake of this example right now. So let's do this eShell. Fire this up. Now this isn't going to give all the complete functionality that most people are aware of in using when using Emacs and Sly. But this will at least get the point across of what I was trying to get at, which is you can if you the errors that you will end up getting if you don't have a subclass, if you don't have the sequence type, built-in sequence type, and you don't have trivial extensible sequences. So for this example, I will use dash q dash l ccl bin run. This should work. Okay. And now let us just take this example, copy it. Let me see if I can do this. Okay. And if we end up, oh, right, I forgot that. This is what I was expecting, which was, as you can see here, we are trying to actually specify a superclass of a built-in class. And unfortunately, the meta classes that we provide from the Lisp implementation, standard class and built-in class, they're incompatible, and as such, it will prevent you from actually going ahead and defining new objects. All right. Now, this is the same that you will get in other implementations that do not support um, extensible sequences natively. Okay, but let's see what happens when we switch over to actually using trivial extensible sequences. Okay, so in order for us to do this, I'm going to go ahead and load. Let me do this. I'm going to comment this out for a second. Okay, and I'm going to load both in here, our SBCL REPL, along with, I will go ahead and load it up into our CCL REPL as well, our workshop, right? No package name. Sequences. The fallback should have actually worked. Error positions in it. Looks like we just found a bug. All right, there is a bug in here. It looks like when I try to grab. Okay, what is the restarts? Try factor make sequences a nickname for dot fallback. Let's see if that works. Let's do 4. All right, I have to use go 4. Hold on. Oh wait, is it C4 to choose it? One second. I have to go and remember which is to pick the actual restart. It is function name. Ah, yeah, that's right. Okay, good. This is C4. Okay, skipping that compile file error, fallback, and process limiter. Okay, so there are still other problems here. So it looks like for the time being, I'm going to have to see why TCL is giving me some trouble here. This is a little disappointing. Um, there might be something that's broken inside trivial extensible sequences, but I can't tell right now off the top of this condition. I have to dig into what it's actually failing on in the fallback. You see, this fallback.lisp is basically the implementation for everything that we need, and so if it's not available, we have some issues there. Okay, um, I will close this up for the time being, and let's close that, and let's get to what we wanted to actually show. Okay, so let me first show this tutorial, and then we may have to do a follow-up when I actually see what's happening with CCL to see how it how it's the fallback actually works inside CCL at least. And I'll try another thing later on in this discussion with what's it with at least ECL. I think I have ECL installed on my machine. Don't want to really spend time installing Lisps while we're talking, and being able to kind of show off some stuff. Okay, let's get back to what I was going to show you. All right. Um, the basic idea of sequences is you need to implement a base set of operations required in order for you to leverage all the API functions that I provided earlier with sequences. And there's a bare minimum of I think actually five functions that you need to implement in order for something to be extended as a sequence. Okay, and we're going to go look at each of them. And for the sake of this, I'm going to go ahead and do this. And I'm going to give you the fully qualified package name just so that you don't confuse this as being the same as the built-in sequence type that's available inside Common Lisp. All right. So for the next couple of examples that we're going to probably come up with, I will be using the fully qualified package name. Um, sorry, I just noticed a comment here. Is this the paper that you related to the proposal paper that we were talking about earlier? I do have I think the paper description. Yeah, I do have that one.
Yeah, I
There.
just I was sort of going on a tangent here, looking at stuff online. What you were just to complement what you're going over, Ram. I didn't mean to
Okay.
interrupt your flow, but I thought
Oh,
that
not a
that was.
problem. Do you have a we'll touch we'll talk into that paper a little bit more. But yeah, I just thank you for posting that PDF. Yes, for folks who are on the Jitsi meetup, we do have the paper provided. I will also post this in the chat for folks who want in the YouTube live stream for folks who want to actually go and take a look at that. And at the end of this stream, like I said, I will post it in the YouTube description, so folks can actually retrieve it later on. Okay, so let me go ahead and restart this because I don't think it's going to like the fact that I'm redefining the class. It's just easier to do this. Let's do this, and let's load up our workshop, and we'll see everything gets compiled. Did I forget to compose? What is the error? Trivial extensible sequences does not exist. I actually, hold on, I may have put in the wrong thing here. Did I? Hold on. Let's go to AFP TS workshop. And did I put in the wrong? Nope, I did not. Okay. Let's see what is going on here then. Okay, hold on 1 second. This should be correct, but I'm gonna wait until I load this before I start looking into this. Okay, let's see here. Let's see what happens when I do this. Sequences does not exist. This is wrong. Let's see. No. Okay, let's see here. That's weird. 1 second. TES. Trivial extensible sequences. Did it not load? No, it's loaded. Let's see here. No, that's not what I wanted to do. BB, no. Slide. This is what I was looking for. Okay. All right. For some reason, it's not showing up as an extensible pattern, which is weird because just the other day I was using this and I got that full path. So something's weird's going on here. You know what? Let's see if I could do this. Trivial extensible sequences. Okay. Does not designate a package. Hold on. Now I have to really apropos sequence. Sequences. So is it interesting. Okay. Let me do this. Because SB sequence is basically the same idea, but I don't really want us to use that. Let me do one more restart and see what's going on here, and then we'll keep going. Before loading my image, let me go ahead and see what disk gets added. Sequence. Okay. Extensible sequences, colon. Okay, let me see in the documentation. Maybe I messed up something. Oh, I may have to just use full sequences instead. They have he may be using local nicknames for this, and that's probably why. Okay, so let me see here. Sequences. Sequence. Let's see if I do this, what happens. Oops, sorry, not that. I want to use find class symbol sequences sequence. Let's see. Sequences does not exist. That's weird. Okay, it is now at this point that I need to start doing some digging into what is the name of the external package that it uses. This is going to be in Lisp, quick Lisp. I think it's in this, I believe, quick Lisp. Installed systems. Nope, let's do quick Lisp software. Trivial extensible sequences. Let's look at the API. Okay, yes, that's fine. Okay. Oh, that's right. He used. Okay, got it. I have to use the full path. All right. My apologies for our small thing. Basically, unfortunately, you're going to have to use nicknames for this, and I'm going on. And nicknames is uh, an implementation dependent issue that I will touch base at some point. But in a nutshell, until further, we're going to have to use this entire name to actually specify the package. Nicknames you can you can specify at the package level through something called package local nicknames. But you I think package local nicknames is only available on SBCL, and I'd rather not go down the path of giving you guys specific Lisp implementation functionality for the sake of discussion. So let me just paste this for my own remembering memory. Let's go ahead and reload our. Oh, right. I better do this first before doing anything. Org dot shirakumo dot trivial extensible sequences. Now this should work. There we go. Let's switch to that package, and we see that we have a defined thing. All right, now we can get going. So like I said, I mentioned that there's about 5 functions that you really need to add in order for us to leverage the sequences API that I kind of showed earlier. And these are the following methods. These are all already generic functions. You don't need to do much, but I'll briefly will name them here. Basically, it's length, ELT for element access, adjust sequence in case that you're dealing with an adjustable vector of some sort, and a function called make sequence like that will allow you to create an instance of your specific sequence. Okay. All of these, as far as I know, have equivalents inside the current running Lisp image. So if we go look up, say, documentation, probably not that one, because that looks like something. Definitely adjust sequence is probably there, right? No. Oh, wow. Okay. So the only two that are part of the core API that we need to deal with is length and element. Now, the one thing about element that I will show in a second is, well, let's just get through it and implement some of these for our um, value as a sequence object here. The first one is the easier one that we'll just pick, and that is um, length. All right. Now, in the case of our value has a sequence object, obviously we're dealing with a single value, so the length is always going to be 1. So this will obviously, oops, there we go. Obviously, will be a pretty simple function to return. Again, for folks who haven't touched Common Lisp in a while, just remember that you are doing a specializer, so you need to go and specify the object here in the signature as to what you're specializing on, and then standard method combination will go and pick it up and say that this is the more specific class when this method is invoked on an instance. Okay. Um, in this case, we're going to go ahead and return 1. This is pretty straightforward. The second one is actually element access that requires 2 different implementations. It's not just a getter that you want to specify, okay? Remember, in Common Lisp, you have something called the generalized, I think the name is it's called a setf expander. So instead of you defining a setter with like set in the name of the actual object, you create an expander that will access the pointer, the reference where this is actually in memory, and then will go and override it. And that's what ELT does for you. Um, let's go ahead and quickly write the getter so we get to the more interesting thing. And the getter here is for a value has a sequence is always going to be um, some sort of index, okay, um, that for the sake of being as formal as possible, we're going to go ahead and check its type to make sure that it is of type integer, okay. Um, and then we're going to go ahead and just return the value of the sequence because, again, since this is a single value, no matter what index you're getting, you're going to get the same value, right? So you can think of it like a constant stream too as well. All right. Here's the more interesting piece of this piece, which is if we go into trivial extensible sequences, and that is if we create a set F expander. Now, for folks who are seeing this for the first time, what this looks like is basically the following. Okay, this internally is telling the Lisp implementation that grab, whatever thing by calling ELT, and then use that reference to actually go in and call this method, this specializer on value as a sequence type. Okay, so what this looks like behind the scenes, and I will show you what this looks like behind the scenes, is oh yeah, I've got the notation is value first, then sequence, then index. Okay, let me first give you kind of this notation, what this looks like. Most people are familiar with how this looks like with vectors or lists, is as if you do ELT list, some index and some value. This notation here, the Lisp implementation will look it up and realize that what we're asking for is could we call the generalized expander, and we'll go in and call that specific method for that specific class. Okay. I'm just kind of going along and kind of telling you how a lot of this machinery works, just in case most people have forgotten on what some of this stuff does. And if there are specific questions that people have, feel free and stop me at any time and kind of ask them. Do you have any questions on that? No, not yet. All right. So let's go ahead and do this is the set f expanders for index. So we're just going to make sure again this is that. And even though we're not going to use it, we're going to go ahead and do value sequence here and value. Okay. All right, so we now have 3 out of the 5 methods that we need to define. The final 2 is really for adjustments. So in case we need to go and create, adjustable vectors or adjustable sequences, it'll be useful to have these 2. And the first one is going to be uh, org shirakumo dot trivial extensible sequences on, let's see, what is it, adjust sequence, which takes in the following. It takes in the sequence, which will again specialize as value as sequence. It's going to take in the length in which we're going to readjust. And then it takes in 2 additional things, which is taken as keyword arguments. First one is initial element. How are we initializing this? And initial contents. Okay. Both of these do not necessarily need to be defined at the same time. All right. Um, it'll be useful if you did, but you know, um, but it's not necessary. Actually, it looks like 1 second. Okay, interesting. For whatever reason, it's giving me a different. Um, that's okay. Um, for folks who looked at the documentation, you might notice that I'm using a different order of arguments than the ones that are provided in the documentation. That is because um, the it looks like the library has changed the signature. It doesn't look like the documentation has been updated accordingly, but that's okay. It's neither here nor there. Okay, so let's see here. This is adjusted sequence length, initial name of arguments. Okay, so now this is going to be for the case of our adjustable thing. We're going to first check to see the type of length is going to be an integer. Okay, now I know for folks, you might be wondering what this integer type is. Um, this is a way of defining a type specifier. It's right now. Um, Forgetting off the top of my memory, like what the hyperspec says about this, but this notation here, just know that this is requiring that you specify something that is a positive integer, um, and this one here is checking that the initial value is 0, I believe, is what it's doing. I have to go and look at that again in the hyperspec specifically. That is, what was it that it was saying about integer? Check type. Let's see here. It was in type specifiers for integer here. Right, you're providing kind of like a lower limit and an upper limit, are to give kind of like a minimum value and maximum value is kind of what this is. So if you wanted to provide, something that says that this is going to be a maximum fixed length of a certain size, you can certainly do so through this notation. Um, let's continue on. Let me just in case other folks are looking at this. So what this is saying is the minimum value of integer is 1, the maximum value of integer is 1, because we are dealing with um, a single value. All right, let's see. Then obviously we want to do this. Why is this contents? Hold on. Weird. My indentation just got kind of messed up for a second there. I don't know why, but we'll easy enough. We'll go and we can fix this. Value sequence. Let's get the first. Since this is a value as a sequence, we're only going to grab the first value of the sequence and return it. Okay, and now we have sequence. Okay, so let's go here and let's get everything kind of. Why is this? I need to figure there. Forget my for whatever reason it is messing up with my notation here. And oh, I see what the problem is. It's this. That's what it is. Okay. There we go. That's the problem. For whatever reason, there was a extra set of parentheses that was causing this all kind of messed up. Okay. There we go. Style warning, initial element never used. Did I mess up something here? Nope. Okay. So, right. So, since we're just doing that, let's go ahead or do this. If, let's do this, and let's create this. Else setf value sequence. Oops, not value is sequence, value sequence with the initial element. Okay. Okay, so now we have no warnings. Excellent. Okay, so now let's go ahead and implement the final thing, which is org.shirakumo.trivial-extensible-sequences make sequence like. Okay, this method is essentially a constructor, if you could, and you could think of it like a constructor for creating your sequences. Okay, this is a particular nice adjustment that they provided, so you can use a single API to switch between different sequences mainly. And this is much like if you've seen map and some of the other generic sequence operations allows you to specify what you're returning, and this is kind of the same idea. It will allow you to create a specific instance of your things without having to specify its type. Well, you could switch between different sequences without having to worry about creating separate constructor calls just by calling make sequence type, and it will use the standard lookup to figure out how stuff works. Again, here I'm going to mention the same thing. If you notice in the signature, I don't know if folks can see in my mini buffer, initial element, initial context are both keyword arguments. If you look at the code that is specified inside the documentation, it will not actually have that. The keyword arguments are going to be flipped. Okay, so little tidbit that you can be aware of. And again, we're checking to make sure that we're getting only a value of 1, because anything greater than 1, and we're going to end up throwing some sort of condition. And then we're just calling the constructor. We're using the generic make instance. And remember, in common Lisp, we have initialize instance that does its own thing to actually go in and when make instance, which calls initialize instance, and it will do its own thing to access and allocate the memory for you so that you get the exact size of object that you're expecting. And then here, for our init arg for value, we are checking to see if either we have the first element in the initial contents, or we specify and if the initial contents is going to be 0, then we return the initial element, or we return the initial the value of the sequence. Okay. So this is now our basic implementation. So now let's go ahead and create obviously a test example of this. Sequence like let's see here, 1, and let's do this, and oh right, I have to specify standard function needs 2 arguments. Did I specify that? Oh, got it. Got it. I'm an idiot. I need to specify the length and let's do this and do initial contents. Well, initial element is 1, and oh, right. Yeah, also after you specify initial contents, that there is no applicable element with initial content 0, initial elements 1. Oh, did I mess that up? Hold on. Oh. Okay, let's do this. SB sequence. You know what? Let's see what happens if I use the other. I'm not going to use make sequence like for the time being, just mainly because there seems to be some confusion for me on what exactly I should actually call that out. No, I thought that this would work the way I expected it to, but for some reason it seems to be giving me some trouble. So I'm just going to go ahead and call value has a sequence directly with value of 1. Okay, well, R2, doesn't matter. Okay. Did I mess something up here? 2, wait. Value has a sequence. Hold on, let me see here. Did I mess something up here? Interesting. Make instance value has a sequence. is a sequence value 2. And if I do this, what's here? When called with arguments, unknown pointer object. That does not seem right. Let me. Okay. I may have to do what he was suggesting. I think this is probably why he did standard object originally. This is why I didn't have to do this the other day when I was looking at sequences. So I'm surprised that this is working a little differently. So basically, for full disclosure, when I was testing this guy out, I was using SBCL on Mac. Um, I'm currently on Linux, so this is a little surprising. Wow. Okay. Can't believe that that actually worked. Okay. Let me see if that also fixes that other issue that I had. Let's do. Doesn't matter what this is. Let's do this. No, no, no. Probably this one. Nope. Okay. So this, for whatever reason, seems to work. Okay. So let's quickly show you what this does. So when you call test on any element, obviously you're going to get this. You know, it's going to be going to give you obviously an error if something's greater than 0. All right. Um, the if it is 0, as you saw earlier, it gave you the value that it needed. If we go ahead and call length on this, all the basic operations should kind of more or less work. All right. If we do map vector, okay, lambda, and let's say we do x to that squares it, and we pass in test, you'll see that it will actually work with all the standard operations. Okay. Um, Again, my apologies for make sequence like. I'm a little surprised that it's not working the way I expected to. I will do some debugging on this and probably write a follow-up video for this. Very quickly, with the time remaining, I will mention this one final piece about this, which is something that was explicitly called out inside um, inside the documentation, and I think it's important to kind of keep track of. Um, what we saw here about accessing stuff, um, this will all work, should work. As you saw earlier, we had some issues loading trivial extensible sequences inside CCL, but assuming that that issue is resolved, then I will dig into that particular thing. Um, Ideally, this code will end up working as is between CCL, SBCL, or any other Lisp implementation out there. Now, that being said, obviously implementing each of these individually could have potentially performance issues. Okay, so you would want to implement some sort of iterator protocol to actually go and allow you to iterate these things um, pretty fast based on how you want to do data access, right? Um, and in fact, the documentation explicitly says that it will make default operations to be performed much faster. Um, and the way you do it is you need to define the following. You need to define actually something called make sequence iterator. Okay, this is another special method specialization. Okay, there isn't much that you need to do here, um, but it's going to return 9 values, all right, to implement the full iterator protocol. Okay, and make sequence iterator. Okay, first to note is the signature. Okay, you will start with the sequence that you want to specialize on. but then you get these two other key values. Are we starting from the end of the list? Are we doing a reverse? And are we doing the start and the end value itself? I'm a little surprised that this is giving me okay. Um, I'm gonna go ahead and put this the way I would expect it will be, and let's see what would happen. Yeah, sequence from start end. Yeah, that doesn't look right. I think it's start end from end. Um, we will see what it would do. Let me actually check something out here. Do I have the yeah? So make sequence iterator is this. Okay, E. Let's go to. I'm just checking to see what the signature is. So because it looks like there seems to be some. Um, my mini buffer is giving me a different extension than what I would have expected it to be. Let's do fallback just to make things easier. All right, make sequence iterator start end from end. Okay, so this is what I was expecting. Why it's giving me from end start end, I have no idea. Okay. Uh, this is something that we'd want to look at. Okay, and if we look at this signature, and we're going to go ahead and implement this for values as sequence in a minute. Um, it's going to return 9 values. Okay. The first value is obviously the iterator pointer that represents the current state value. Okay, the iteration state value. The second one is the uh, limit, and that is the end of the actual index that we're going to actually deal with. So you are saying that basically when you're iterating, the maximum number of times you can iterate through the sequence is limit. Okay, so in the case of value has sequence, it's going to be 1. Um, from end is for reverse iteration. And we'll go through each of these individual step functions one at a time. Okay, so let me go ahead and do this to make things a little easier for us. And that is, I'm going to split the screen and let me go ahead and pull up our implementation here. Okay, so the first thing we're going to implement is, since this is going to be returning multiple values, we're going to use the values operation. Again, and values is going to give us a collection after which, and we will then go through each of the other uh, return values of this function for implementing the protocol. So first one, we said it's going to be the iteration state value, the limit of iteration. So think of this, if you're coming from C++ as your start and end, or 1 plus over end of the pointers for iteration. Um, from end, since it's being passed in as an argument, we could just go ahead and return it like this. And then we are going to have various Lambda functions that's going to implement all the various other functionalities for iteration. The first one is a step function to tell us how to get to the next state. Okay, and we do that. This will take in 3 arguments: the sequence that we're dealing with, current state, from end, and let's say that we're just going to increment the current state for this, okay, for the step function, okay. Um, and this is obviously just returning the new state value for the current sequence, okay. The next one is going to be a predicate to see if we've actually hit our limit for iteration, okay. So again, this is going to take the sequence, the state, the limit that we passed in and whether or not we're coming from the end. And in this case, we're just checking to see how many times we've iterated. Okay. Um, so now what's that? This is first, second, third, fourth, fifth. Okay. Number 6. This is going to be a read into the actual sequence. Okay. And this is going to take simply just a sequence and a state, and we're just using value sequence. Okay. Ideally, you'd probably want to declare state as being ignored inside of this lambda. Um, but I won't clutter the code for the time being. But that's just kind of some hints to the compiler to allow it to optimize out unused variables. But because the signature in some cases require you to use the state, it's part of the actual interface signature. Okay, just keep that in mind. Um, the Since we provided a read, we obviously need to provide a write. So the next one is going to be a write um, for iteration protocol. And obviously, we've written this one before enough times that I don't think I have to explain that. That's pretty self-explanatory. The last two functions are really dealing with indexing into, well, what the current index is in the sequence that we're iterating, and whether or not we are copying the actual sequence or not, a copy function. Okay. Um, so for the index, this is just basically state. Okay. Because we're treating state as the current state of the sequence. You could certainly name it slightly different, but for all intents and purposes, for this particular implementation of the iterator protocol, state is the current state in the sequence. Okay. For copying, we're also going to make it the same function in this case. Okay, this is the example that Chimera kind of provided. And it makes sense again because, again, since it's a value as a sequence that's treating a single value, your state's never going to necessarily change in a sense beyond it being the first value or the end of the iteration. So its copying will make complete sense here. Again, we're not doing a I don't believe this iteration function here, this copy function, for those who are looking at it, it's copying the so-called collection. This is not a copy sequence function. Okay, this is a copy iterator function. Okay, so that's a very clear distinction between the two. All right, that's another reason why for the sake of this example, it's pretty simple. Once you do this, and again, you could see all the style warnings that we're getting here. And the easiest way to fix these style warnings is by just simply doing declare ignore sequence state. Hold on. For whatever reason. Okay. Okay. Seek is defined but never used. Okay. And let's do this. Ignore seek and state. Oh wait, seek and from end. Not, there we go. That's what I was doing. Wrong. And let's do this. As you can see, the code gets a little not cumbersome, more so than uh, what am I looking for? It is it looks a little more what's the word? These are more involved than what they should be. Okay, these I could keep going on this, but I think you get the idea that this is basically hints to the compiler to say, hey, these are ignored, unused variables. Don't worry about them, and it will go through it. Once this iterator is implemented, um, um, you can then now use this with not just sequence iterators or with sequence iterator functions or do sequence. It allows you to then take these methods and then implement generic algorithms for each of the individual overloads for the sequence API. Um, so I'm gonna end it here. There's some interesting stuff that I wanted to show on this, but I wanted to give this a preliminary presentation. Next time, I'm going to try and show you on how we use this trivial extensible sequences to do two things. One is creating a generator sequence, which will take in a function and essentially create potentially an infinite stream. Doesn't necessarily need to be one. This is much like what Series currently does for us. And but then we'll have the ability to access the sequence APIs with it rather than using Series specific APIs. And the second thing that I was going to show you is files and streams, just to give you an idea on how to interact with this with IO streams. But I will stop my discussion here for today on this and leave the floor to questions, comments, or just general discussion topics. Any questions at all? I mean, I'm opening the floor now. I
I had a question, Rom. So,
yeah.
um, is there a can you show us a case where you, let's say, would normally use this extensible API sequence API, but what would you do if you weren't able to use it? Like, how would you approach that problem?
So if I'm understanding you, you're asking what if extensible sequences API
Yeah, what if that didn't
is
exist? What if that didn't exist? Like, what would be the workaround that you have to do?
okay. So if this library didn't exist, what would you have to do? And let's even go even further and say, let's say that your Lisp implementation doesn't actually implement extensible sequences like SPCL does, as we saw earlier. Um, In that situation, you have a couple of options. The more common best practice is as you're creating a non-standard extension API for your data structures, and hopefully comment in the appropriate places that this is a sequence, sort of to give Lisp implementation authors kind of a hints that, oh, this is yet another data structure, another motivation that we should have to actually implement this functionality. Remember, I think I've mentioned a couple of examples of libraries that already do this. Climax is one that actually leverages it. There's buffers. There's a library called FlexiStreams that implements sequences as well, that have their own APIs for iterating through their sequences and iteration. Um, each of them, though, essentially are hints at the specific Lisp implementation author that extensible sequences really should be available. So a lot of this code duplication and API duplication, which is a big thing. I know a lot of folks think that API duplication may not be a big deal, but it is really a big deal for the maintenance programmer. All right, because if I'm coming in and I'm now dealing with 6 different collection APIs, all right, which can happen, by the way. Uh, if you look at maintenance code from, say, and this is not even specific to Common Lisp, any commercial code base or even open source code base for, say, Java. It's probably the most recent example of this. Um, you might end up encountering some collections that are using java.collections. All right. They might be using Guava, which has its own collections API. They might be using uh, Apache Commons, which has a bunch of collections too that may not be standard. All right. And they have their own API because they want their own flavor of how to interact with sequences. It becomes a little, difficult, right? With Common Lisp, I think one of the advantages of it is at the outset they kind of realized that they have this ability to consolidate, and if they just went a little further and recognized that, oh, wait a second, there are a lot more than the current built-in sequence types that people might provide. If we gave them the ability to actually leverage our current existing generic algorithms, we might end up having more advantages and opportunities for extension. Um, I think it would have gone a long way. Other questions and comments? Let me see if there's any in the live stream. If not, um, all right. I mean, if not, I'm going to go ahead and say thank you all for joining. I appreciate you all joining for this time, and again, I'm glad for those our regulars who are coming back, um, and apologies for the long hiatus, but we're now getting back to things, and hopefully, I can give you some more interesting talks as time goes on. I hope you all have a good evening. Before I let you all go, just a reminder, Atlanta Functional Programming is hosting a talk on Introduction to Functional Programming using Free Pascal, um, December 6th, Wednesday, 8 p.m. To 10 p.m. Eastern Standard Time. We are doing this as a joint meetup with the fine folks over at Tucson Functional Programming. And I will be essentially going through and kind of giving a overview of how to use the new features for function references and anonymous functions that are now available in Free Pascal. I hope to see you all there. Otherwise, I will see you next week. Thanks.
Thanks, Rom.
No problem.